look at an example of a deductive reasoning. And just like what you see here, a deductive reasoning starts with a general rule. So it gives you a conditional statement. Okay? And like earlier, you had to come up with a rule. This time the rule is given. And then you will apply the rule to specific examples. Okay, so all right. Is our response supposed to be the conclusion? No, Adrian, your response is to have a true statement, and then you apply it to specific example, and then you write down the conclusion. Okay. For example, if I am in Mrs. Arciaga's period 5 class, then I am awesome. So I am enrolled in Mrs. Arciaga's class. Therefore, I am awesome. I am awesome, right? So that's a real life example. So you have to come up with something like this. Come up with a rule, okay, and then apply it to specific example. So you have to type 3 parts. The first is the general rule. The second is you apply that rule to one example, okay, by using only the hypothesis. You see this one? The hypothesis is something is a triangle. So the hypothesis is that one. Something is a triangle. And then the conclusion is you take the conclusion of the true conditional statement and state that that is true. It doesn't have to be in geometry, but I would appreciate it. I like it better if it's in geometry. Nice. That's a good one, Jeremiah. So can I share that, Jeremiah, while you're typing it? So Jeremiah starts with, if ABC form a right angle, then it sums up to 90 degrees. Okay, that's a good one. But maybe take out the ABC and put that in the second part. Maybe you can say like, if an angle is 90 degrees, then it's right. Or if an angle is right, then it's 90 degrees. And then you put the ABC in the second portion, like angle ABC is right. Therefore, something like that. Okay? Awesome. Yes. Uh-huh. A polygon is a quadrilateral. That's a great start, Edward. I kind of like where your example is going, Edward. It's kind of related to what we will do later. Keep going. Build up on that. Nice, Ilana. If an angle is less than 90, that's a good one. If a polygon is a hexagon, yep, that's a good one too, Caitlin. Build up on that. All right. If an angle is 90, then the sum of the angle measures 90 degrees. Oh, that's a double dip, Nicholas. In English they call that, what's that word? Redundant. Okay, so maybe change one of the parts to like right. So maybe you say if an angle is right. Yeah, if an angle is right, then okay. Oh, he's tweaking it, Jeremiah. And I'm pretty sure like he will also make it unique. Yes? Thank you. So Johnny, we're going to write like a conditional statement. Something like you see on this slide. So you come up with a general rule. If a polygon is a triangle, then the sum of the angles is 180. Thank you, Jeremiah. And then you will give a specific example to which the hypothesis applies. There you go. And then for the conclusion, you just state the last portion of your conditional. Oh, that's a good one, Adrian. If a polygon is quadrilateral, then the angle measures sum up to 360. Okay, but Adrian, since you said it's a quadrilateral, then you have to add another letter to your EFG because it means it has 4 sides, right? Awesome. But that's a good one, Adrian. That's a good one. Okay. Very good, Ben. Okay, so now you just have to say the name of an angle. Let's say angle 1 is. Can you guys please share your answers to the whole class? Because I think this is something that we need a little bit more time on. So can you also share so they have at least some models to follow, or get ideas from your response? Awesome. That's a good one, Giovanna. Edward, that's not complete. Keep going, honey. All right. Very good. If a polygon is a hexagon, then a sum. Nice one, Caitlin. Polygon ABCDEF is a hexagon. Good job. Awesome. So then the sum of the angles of A, B, C, D, E, F is, so you have to mention the A, B, C, D, E, F in the conclusion. Good job, Caitlin. Kiloa, very good. If an angle is more than 90, then the angle is, okay, I can see where that's going. Good job. Maggie, if an angle is straight, it's 180. Awesome. Angle AB. Oh, but don't say angle AB. You have to put 3 letters because the minimum for angle is 3. Just make it ABC. Nice. Matthew, acute. Ooh, okay. Matthew, if I may make a comment on that one. So you have to use the hypothesis of your conditional. It's your if part is the angle is less than 90. So that means your hypothesis has to be like that. Let's say angle, blah, 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 um, is less than 90 degrees. Okay. All right, Maggie, give me 1 sec so I could go back up. Did I? Oh shoot! I lost it. Sorry. Where? Okay, nice one, Maggie. Yeah, that's right. Rihanna, if an angle is greater than 90, okay, then it's obtuse. Awesome. So angle ABC is greater than, okay, so the conclusion will be um, the sum of the angles is greater than 90 degrees. Nope, Rihanna, you have to like follow the order over here. So let's say your hypothesis would be angle ABC is greater than 90 degrees. So you still have to follow the same order in the conditional. So hypothesis would be angle ABC is greater than 90 degrees. There. Your conclusion will be then angle ABC is obtuse. There you go. Rocky, come on, come up with a conditional. All right, I know this takes a little bit of time, but it's good to know that some of you have started. And um, please share your screen with the rest of the class. I do not normally ask you to do that, but yeah, okay. All right. Okay. Can you leave that slide um, for now so we can move on? You can go back later on and fix it. Okay, one more and then we're going to go to our breakout rooms. So on slide 5, please. Slide 5. And you can come up with your examples again later on. Slide 5, another type of deductive. So remember, for those who just joined us recently, we're talking about 4 types of reasoning. We've done the first one, which is inductive. So go back later to slides 1, 2, and 3 to study more about that. Now we are going deductive reasoning, which is from a specific generalization, like we come up with specific examples. Okay. And now we're looking at another type of deductive reasoning, which is called the law of syllogism. So it's like in English when you have those. Okay, help me out here. I'm not good in English. So when you have those simile, metaphors. What did you learn from Miss Baker last year? Hyperbole. Is that what you call them? So that's what we're doing today. Like we're looking at the different types of statements that are used in geometry. So similar to those, that you did in English. Okay, so law of syllogism. For example, the first statement is, oh, by the way, they don't go like number 1, number 2, number 3. Like I just wrote the numbers so you would know the order. The first statement is, if a polygon has 3 sides, then it is a triangle. That's one conditional, right? One if-then statement. And then you're going to follow it up with another if-then statement by now using the conclusion part. So you see here, this is the conclusion, and then they repeated using that in the second if-then. And in this one, the sum of its angles, okay, will actually repeat over here, right? And in the first part, the circle one, there you go. Okay, did that make it more confusing? Okay. So I did it like how it would like. So it is a triangle repeated over here. The sum of its angles right there. and then the polygon has three sides repeated in number 3. So all those three statements were like combined in number 3, right? Does that remind you of a property in algebra that we talked about last year? When you're comparing three different stuff, and then you knock one of them out, you know? What property is that? Like you compare three different quantities, and then you drop one of the three and compare the remaining two. Does that sound familiar? No? This one is similar to, can you tell me what property this one is in algebra? What property is that? The one that I wrote on your screen. Who remembers? Dun 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 dun. Who remembers that property? I do. What is it, Jeremiah? Starts with T. T. All right. Starts with T. Jeremiah knew the answer, but he wanted someone else to share. The blank property and starts with letter T, Matthew. T. R. Train. TRAN. Transitive. Very good, Brian. Yes, transitive property. Yay, there you go. So, law of syllogism is like the transitive property. Okay? When, they're sharing the same part of the statement, and then you drop the common part and compare the first and the last. Nice. Okay, so while you're finishing up your example, please share your example to the class. I know sometimes I teach you to be selfish and not share the answer, but at this point, could you please share your responses to the class? And I like how you guys are using geometry related examples. Love it. All right. Okay. While you're finishing up, I'm going to just prepare my screen so we can all be ready for the breakout rooms. Okay. We're going to do patterns. We will apply what we just learned about, like inductive and deductive reasoning. And if you don't finish this Desmos, then I will adjust the deadline. Okay. All right. So finish up your sentence, and I'm gonna set up my breakout rooms. I need 10 groups today. Oh, nice, because we're 30 something. Okay. Okay, so let me share my screen again. All right, so now let's go back. Let's leave that slide for now, and let's go to Schoology. Inside Chapter 2 folder, you will see a Google slide deck. In the Google Slides, right, in the Google Slides, oops, I don't think we have enough students. I'm going to delete one room. Okay. All right. Okay, just making sure that we have at least 3. Okay. So, if you could please open conditionals and patterns in Schoology. So click on that. It should open a Google slide deck that looks like this. We're going to skip number 1 for now because I think you did very good in the examples for the conditional. So we'll skip number 1. Let's all go to number 2. Okay. So for slide number 2, this explains how you will do the breakout rooms. You will be assigned to the breakout room, and that breakout room corresponds to a pattern number. So there are 10 patterns that you will see in this slide. I ditched the Jamboard because it couldn't accommodate all of us. Um, so your smart brains overwhelmed it. So we're gonna do a Google slide instead. Okay, I think Google Slides can handle all of us. Okay, so now that we're all logging in, I think it's having a difficult time. All right, hopefully it will load properly. Okay, so I'm going to open the breakout rooms right now. If you are in breakout room number 5, then that means you will be going to pattern E. And once you get to pattern E, what will you do? You will use either text boxes. This time we don't have post-it notes, but you can color your text boxes, and don't forget to write your name. So insert a text box with your name and explain how the image is growing or how it's changing. Or you can also come up with a rule. You can type it if you don't want to draw it. You can also come up with a rule, and use that rule to draw or write the next one. Or if you want, you can simply describe it, describe the rule that you're using. Okay? So I'll try to go to all the breakout rooms again. Pardon me if my internet is too low, but I will give you instructions when it's time to leave the room. So we'll do this in only about 5 minutes, okay? All right, and the rooms should be open.
Then now I just need Daddy to check my math for whatever's wrong there.
All right, so welcome back to the main room. Okay, so how was that? All right, so in that activity, I wanted you to, experience how, um, how inductive and deductive reasoning are actually similar and or different, similar to and or different from each other. Okay, I think in some of the in some of the examples you had to use inductive because you had to look at the pattern and then you have to come up with a rule, and then once you have the rule you go in to apply it to find the next number or maybe to find the next pattern. So I hope that you were able to have like you know a great experience in that. Okay, so later on you will have a chance to do some gallery walk, just browse through, the slides, and if you see something that the original team members did not write about, then maybe you can add that up as a comment. Okay, all right. Now my system is just slowing down. It says unable to load file. Okay, so here in your graphic organizer for geometric reasoning, we have already talked about the first two types, which are inductive and deductive reasoning. So what we're going to look at will be the next type of reasoning, which is about conditional statements. So we have already mentioned this in chapter 1 when we were writing definitions, but um, we will be defining them today formally. So if you could please jump to slide number 8. Okay. Slide number 8. Thank you. You just write down the name, Adrian. You don't have to explain them. Because the explanations are also in decimals. If you want, you can copy and paste the meaning from decimals, and you paste it in your graphic organizer. That's the fastest way to do it. Okay, so somebody mentioned earlier all 90 degrees are right angles. So how are you going to write that? For now, yes, Rihanna. Yeah. So you would have an idea of how to do the rest because I don't want to just like dump them to you without going over them. Okay. So we are now going to rewrite the regular sentence. All 90-degree angles are right angles. And maybe you're wondering how to start. So remember, definitions are two-way conditionals. I know I'm being glitched out too, Caitlin. So don't think that it's only you. And this is the nth time today for some reason. All right, it could be because a lot of, yeah, I don't know. Yeah, but thanks for being patient. So you're going to write all 90 degrees are right angles. I don't know if you started writing and I just don't see it, or my screen is glitching out again. I'm so sorry. But I should be the only one zooming right now by this time. I'm going to keep refreshing it. All right. Yeah, about 10 to 15 minutes remaining. We got this. Nice, Ben. That's a great start. All 90 angles are right angles. Rihanna, can you write that down in like an if then statement? So rewrite as a conditional, meaning if an angle is right, then its measure is, or it could be the other way around. If an angle measures 90 degrees, then the angle is called a blank. Awesome. All right. Great. And this chapter, we are also going to start with proving. So soon you will realize why it's important, to know which one must we use as a hypothesis and which one must be the conclusion. I will be asking you to not memorize, but at least, be able to identify the reasons for every step in the proof. So writing if then statements will be very, very important. If it's not in an if then statement, it will be marked wrong. So you should know, just like in English, you identify the subject and the predicate. Correct me if I'm wrong, but in math, you have to identify the hypothesis and the conclusion. Okay, that's great. Hey, Mark and Alice and Rocky, I'm sorry if it's glitching you out. Yeah, but you can go back to it later on when there's less internet traffic. Okay, so now let's move on to the other types of conditional statements. If you go to um, if you go to slide number nine is talking about the negation. It's just a fancy name for the opposite, pretty much. Yeah. So if the original statement is angle one is a right angle, very good, Nico. That's the way to go. Yep. You want to share that? Yep. Okay. Share your answer, Nico. Either in decimals or say it aloud. So you just pretty much put the negative, okay, by inserting the word not. Is not a right angle. Awesome. And why is that important? You will see in slide number 12 why that negation is important. Yeah. Okay, like Mr. Arciaga is awesome. Mr. Arciaga is not awesome. Something like that. Okay? Cool. Next. 10. Converse. Converse. To write the converse, pretty much you reverse. All right? Thanks, Matthew and Maggie. Um, so to write the converse, ooh, I forgot to put write the negation of the statement. Pardon me for that. That's not correct. So write it should be write the converse. Dang, Arciaga. They just said you're awesome and then you messed up. Dang. Okay. So can you chat the oh, not today, Jeremiah. Yeah, on that aspect I'm not awesome. Okay, so write the converse of the statement. There you go. Write the converse instead of negation. I messed up. My bad. Okay. I was probably sleepy when I did that. Okay, I know this one takes time to prepare, but I love it. It's like seeing you in person. So if the sum of the measures of two angles is 180, then they're supplemented. So flip them around, switch them around. Yeah, that should have been write the converse instead of write the. Oh, I can't edit it now. It will like kick you out of the thing. So I'll edit it later. There. So just flip them around. Very good. So if um If two angles are supplementary, then the sum of their measures is 180. Very good. Okay, Ben, flip him. Benjamin, Carrillo, flip them around. So if two angles are supplementary, that should be the first one. So the subject becomes the predicate, and the predicate becomes the subject. Something like that in English. So yeah, flip the if and the then part. Awesome. I'm sorry, Mark, if you got stuck, if your slide got stuck. Hopefully you'll be able to catch up later, honey. Okay, and my thing is being screencast too, so yeah. All right, nice. Great. Okay, so from conditional statement, we went to negation and then we went to converse. So now there's two more types of conditional statement, and Nico is way ahead. Nico together with Alice, Arundeni, Ben. Oh no, okay, no, I can't keep up with the names now. That's a lot. Okay. All right. So now you're gonna write the inverse. To write the inverse, you have to negate both the hypothesis and the conclusion. So you have to write down the opposite of the hypothesis and the opposite of the conclusion. If the angles are not but Nico, you don't flip them around, yeah? You still have to follow the same order. Don't flip, just negate. Don't flip, just negate. Yeah. If like a non-geometry person can hear us talking about that right now, like sounds weird, huh? Don't flip, just negate, right? The negative or the negation. Okay. Nice one, Rihanna. Lilian, okay, very good. Caitlin, great start. Gianna, very good. Yeah, that's right, Gianna. Sometimes you have to like rephrase it as well. That's fine. There's nothing wrong with that. Uh huh. That's great, Ilana. Um, all right, honey, give me one sec. I'm going up the screen and see. Um, Edward, very good. Bianca, Ben Cruz, Arundeni, Adrian, good job. So don't flip, just negate. Don't flip, just negate. Yep, Maggie. Lillian, that's right. Linnea, very good. Kiloa, awesome. Yep, just finish that up. Caitlin, good. Good start, Caitlin. Finish. Giovanna, very good. Awesome. Ryan, yay. Okay, so that's how you make the inverse. Inverse. So inverse is different from converse. All right. Last one. 12. Contrapositive. Contrapositive. So converse and contrapositive. So your clue is when you see the prefix con. Is that a prefix? No, maybe I'm wrong. So if it has con, C-O-N, that means you have to flip. That means you have to flip. Okay, so converse and contrapositive, they both flip. But contrapositive is, it's like a double negative. You flip you flip the negation of each one. Okay, so to write the contrapositive, you write the converse first, meaning you flip them around, and then you negate both the hypothesis and the conclusion. So flip around, and then put the not part in word, the and not supplementary or not equal to 180. So this contrapositive part is important when you guys are making counter examples, and that's going to be part of your homework. So there will be, one slide in your digital notebook in which you will find a counter example to a statement. Okay. Yep. Something like a counter example is an example that makes the statement false. All right, so now that you've written, I'm going to scroll down. I have to see the word not 2 times, both in the hypothesis and in the conclusion part. Yay! Okay. All right. Very good. If I don't mention your name, that means you're doing it right. Okay. Great start. Keep going. Awesome. All right. I can see that you guys are getting this one. I love it. Okay. So finish your thoughts, finish your sentence, and um let's go to 13. Okay. And then I forgot to switch the title. Hey, I was probably really sleepy when I was working on this one. So this is biconditional. Biconditional. Okay. So when a conditional statement and its converse are both true, you can write them as a biconditional. Those are the statements we talked about before, which uses the if and only if. So now recall the definition of adjacent angles. And I want you to write that as a biconditional statement. Write the definition of adjacent angles. Don't start with the word if. The if and only if has to be in the middle. Something like two angles are complementary if and only if they add up to 90 degrees. But yours is adjacent angles. So two angles are adjacent if and only if, okay? That's how you start. Two angles. Nope, Edward, that was just an example. Use adjacent, honey. So two angles are adjacent if and only if. Okay, so what comes after that? If and only if they are right next to each other. Okay, so that's a good one, Rihanna. But be more specific. When they're right next to each other, what do they share? What are those two parts that they share? If and only if they share a common blank and blank. Two angles are adjacent angles if and only if they share a common blank. Very good, Kiloa. That's one of the words I'm looking for. Vertex. Good job, Caitlin. And she got the other one. Awesome. Awesome, Caitlin. Two angles are adjacent if and only if they have a common side and a common vertex but don't overlap. You can also include that or they're non-overlapping. Awesome. You can also, write that in a different way. Let's say two angles share a common side and a common vertex if and only if they are adjacent. So that's what we mean by biconditional. They could go either way. And all definitions in geometry should be biconditional. Good. Second to the last one. Okay. Second to the last one. Am I over time? 105. Oh, yeah, I'm 4 minutes over time already. Okay. But let me just explain what you guys are going to do. So, yes. Um, for number 14, you will write down the converse, inverse, contrapositive of this definition. So you will be writing, three conditional statements. And if they're both true, you have to write a biconditional. Yeah? Yeah, I'm okay with going over time too because I can't get enough of you guys. Dang it, you guys are so awesome at this one. I miss all of you. Okay, go COVID, go away. We're missing out on this batch. All right, yay! So you have to write all those, and then, so one answer for each. Yep. Okay. And while you're doing that, I'm gonna make some commercials. There's back to school night today. However, I do have a teacher training to attend. Yes, because I'm learning new stuff that we could use in class. And it was scheduled prior to when the school announced the back to school night schedule. So I'm so sorry, but I cannot join you. However, I did send everybody a message through Schoology that you can find the video in the school's website. Um, Most of you are in STEAM, so you also receive an email from Mrs. Arciaga. Okay, so you can just watch the videos. I created screencasts and uploaded them. Okay, and if you Um, if you don't want to go to the school website, I also I also posted an update in Schoology, so you can find it there. All right, so you're gonna complete that one later. You must have three answers: converse, the inverse, and the contrapositive, and then you decide whether you can write a biconditional. Okay, and remember, the only time you can write a biconditional is if the original and its converse are both true. Okay, and of course, last but not the least, let me just explain how you guys are going to do this. I will extend the deadline of this one because definitely we didn't finish it. Um, so you'll have more time to do it. And the last slide, all you need to do is you are to decide whether it's true or false based on the diagram. If it's true, then write a conditional statement, like a definition, supporting it. If not, write also the definition that it violates. So either way, you will be writing a definition, for those keywords, for supplementary, for midpoint, for vertical, and for perpendicular. Okay, but you will decide whether it's true or false. Okay, all right. And I will leave this open so you guys can finish it. I won't grade until probably I have to change the deadline because I'm gonna forget. I always forget to fix that. Today's the 24th. There's no school on Monday. So can I just move everything to next week? Is that cool? I don't want to work this weekend too. We should have fun. I'll probably just grade makeup work this weekend, but I'm not going to grade new work. Let's all agree on that. 28, what's biconditional? Oh, biconditional is like an angle is right if and only if it measures 90 degrees. So that means you can only write a biconditional when the original statement and its converse are both true. Yeah. Oh, yeah. I can imagine you saying, Maggie, oh, yeah. All right. Okay. So, deadline on the 28th? Yes. We're cool. Yeah. And so, after you do the decimals, like write down all the things that you learn in the digital notebook so you don't forget. Okay. So I don't know what I put in the digital notebook. The deadline for the digital notebook is, yeah, instead of like making it all due at the end of the chapter, I'll just try to, um, sure, no worries, Jeremiah. Bye, honey. I also put the digital notebook on the 28th. Would you like me to add another day? Yeah. Okay, let's go. Let's go. We will meet on the 29th. So I'll just put it on the 29th so you have at least a day extra because I don't even know if I can check it before then. All right? Yeah, I check when I get bored or I'm watching TV at night. Alrighty, you guys. So if you